All right, here are solutions for quiz 6 for Math 211. On this first problem, you are given 5 methods and 5 problems, essentially. You say we have this Cartesian product method, which is for multiplication, this tree diagram, also multiplication, repeated addition, another way to model multiplication, and then the partitive and measurement methods of division. And what you're given are these 5 problems and kind of told to match them up. So, okay, on this first one, I'm cooking nachos. I have 3 different types of chips and 4 different types of cheese. So the first thing to recognize that this is clearly a multiplication problem. And that's because it's asking how many different combinations could one make. So you can kind of choose one of the 3 types of chips, chips, and then one of the 4 different types of cheese. So how do you model that? Well, that's where it gets a little bit tricky. We have 3 different methods of modeling multiplication: Cartesian product, the tree diagram, and the repeated addition. You could probably use any of them. I think it would be hard to justify repeated addition here, but these two, Cartesian product and tree diagram, I bet you could make a decent argument either way. I'm going to say Cartesian product. So the way I would think about it is kind of, you got chip 1, chip 2, chip 3, and chip 4. Okay, you know what? Let's write this out more intelligently. Let's say you have one set of chips, and maybe we'll call those 1, 2, 3, and 4 to represent the 4 different types of chips we have. And then you have, there's only 3 different types of chips. Sorry. 4 different types of cheese. So I don't know, maybe they're A, B, and C. American, Brie, and cheddar. It'd be kind of nasty nachos, so never mind. And the point is, you're going to try to make a combination. To make nachos, you need a chip and a cheese. So you can kind of think about your nachos as equaling the set created from finding the Cartesian product of chips and cheese, something like that. And you're like, yeah, well, you said that I could use Cartesian product or the tree diagram. Why'd you choose that? Well, if you jump down to part D here, I'm cooking nachos. I have 3 different types of chips, same story, 4 different types of cheese, but now I have 2 different types of salsa. So how many different chip, cheese, salsa combinations can I have? Well, this is still multiplication. But now really what we're doing is we're multiplying 3 times 4 times 2. And we don't have a way, or we didn't learn in our class, how to use the Cartesian product when you have 3 different sets: chips, cheese, and salsa. So you could not use the Cartesian product down here, and I think it would be really difficult to use repeated addition. Since you have 3 different choices to make, your tree method makes a lot of sense. So you kind of pick your chip here, and then regardless of which of these chips you chose, you have 4 different types of cheese. Kind of squeeze those in. And then each of these kind of tree branches here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, represent a chip-cheese combination. And for each of those, you'll make the choice of what salsa you want. So sort of this one splits off into 2, this one splits off into 2, 2, 2. And you don't really have to draw all the different branches of the tree, but I've gone this far, and I'm going to try to squeeze them in there. Yeah, good enough. So I'm going to use the multiplication in the tree diagram here. And so since I'm forced to use it here, I really can't use it up here. And since it said kind of match these up, one method for each of the 5 types of problems, this would have to be Cartesian product. I'm cooking nachos. A serving of nachos requires 3 jalapenos. I have 12 jalapenos. How many servings can I make? Maybe you would notice that this one represents division. I'll put it on hold for now. Is it partitive or measurement? Hang on, we'll talk about in a minute. I ate 6 nachos during pregame, 6 more at halftime, 6 more after the game ended. How many nachos did I eat? Well, you ate 18 nachos because you're multiplying 6 and 3. But really, the way this is laid out, how you kind of did 6 and then 6 more and then 6 more, that kind of suggests repeated addition. So sort of 6 plus 6 more plus 6 more. If you want to do it on a number line, you can be like, I ate 6 nachos, 1, 2, 3, 4, 5, 6. Actually, I don't like this problem on a number line. Sort of think about it like you got 6 nachos. There they are. That's the pregame nachos. And then the halftime, you ate 6 more nachos. And hey, here they are. And then after the game ended, you had 6 more, cold at this point, but whatever, nachos. And what you're doing is kind of putting these guys all together to represent all of the nachos you made. These are your 18 that you got from repeated addition. So presumably E is going to be division as well because I have 2 methods left. The 2 division ones, and I haven't talked about those yet. So let's look at the difference here. Here you made 24 nachos, but there's 3 people splitting them. So you're starting out with a group of 24. It's a bit of a large number to represent here, but if you're going to do it, I guess I should too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Good enough. I made 24 nachos, but there are 3 people splitting them. So you already know how many groups you're going to split these up into. There's one group, there's another group, and there's another group. How many will each of us eat? Well, if I take all these 24 and I kind of allocate them, 1, 2, 3, 4, 5, 6, and I want to make sure I allocate them evenly, what you'll end up seeing is that you end up with 8 nachos in each of these regions. So what did I just do? I was told how many groups I would end up with, and I was asked what will be the size of each group. So I took these 24 right here, and I partitioned them into 3 different groups. So this would be division. I don't know why that says divisions. This would be division, and specifically it would be partitive division. Whereas up here is similar. This time instead of having 24, I have 12, which is nice because I didn't want to draw 24 of something again. I have these 12 jalapenos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I don't know how many servings I can make, so I have a question. I don't know how many groups I'm going to have down here. But I do know that each group has exactly 3 in it. So I can get one group with 3, and then there's another group with 3, and now I've used up 6 of them. And then another group of 3, so now I've used up 9 of them, and another group of 3. Now I've used up all 12. I have 4 groups, my answer is 12, but this is the measurement method of division. Because I'm measuring out groups of size 3 from my initial 12. So I didn't really justify in writing, but hopefully I talked through enough why I used each of the different methods. Let's move on to number 2. Number 2 is a puzzle. What you're doing is testing your knowledge of order of operations by filling in digits, the digits 1 through 9. So I'll write those somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9. You're putting 1 through 9 in these 9 boxes here, using each digit exactly once, and you want to make true statements. So something divided by something plus something equals 8. So where do you even start? Well, fortunately, there's a hint. It says, first figure out the number in the top right, this guy right here. How can I figure out this number right here? Well, if you're thinking about order of operations, note that you're going to do this division before you're going to do this addition right here. And if you think about this going downwards in this direction, you are going to do this multiplication before you do this addition. So I'm going to take some number, multiply it by some other number, and then add something and get 61. 61 is a pretty big number. This number right here is going to have to be pretty big in order for me to multiply it by a number and then just add some single-digit number and get 61. It has to be big. But it can't be too big because I'm going to divide these numbers and get something out of this division sign. And then I'm going to add to that and only end up with 8. So how big can this number be? Well, if you look this way, something divided by something, this is not going to be equal to 1. Because for it to be equal to 1, I'd have to put the same number here and here. And if I use the same number here and here, I'd be reusing the same digit. So this quotient cannot be 1. So at the very, very least, this quotient is 2 right here. So at the very most, this number is 6 right here. So this number, at the very most, is equal to 6. It might be less than 6. It might be 5 or 4 or 3 or 2, something like that. But at the very most, it's 6. Well, if it's anything less than 6, I'm going to get in trouble going down. Because if it were 5, for example, 5 times the largest this could possibly be would be 9. 9 times 5 is 45. There's no way I can get to 61. So this has to be at least 6 in order for me to be able to get this up to 61. So it's at most 6 going this way. It's at least 6 going this way. It's exactly 6. 6 is gone. What does 6 get multiplied by so I can get up to 61? Well, a pretty big number. Could it be 8? 8 times 6 is 48. 48, I need 13 more to get to 61. That ain't going to work. So I guess it has to be 9. 9 times 6 is 54. 54 and 7 more would give me 61. So what I've did is I figured out the number in the top right and the 2 below it. The next step is to figure out the number in the left column, middle row. So supposedly I can figure this thing out. No, middle row. Left column, that's this column, middle row. So yeah, this guy right here. Well, it's small. How do I know it's small? Well, because the sum of these 3 numbers is only 15, and I'm using up 9 of them right here. So this plus this can only be 6. It can't both be 3, so what that tells me is either these 2 numbers are 1 and 5 or 2 and 4. So this number is either 1, 2, 4, or 5. So which of those is it? Well, it has to be big. How do I know it has to be big? Because I'm going to multiply it by some number, and I'm going to get a number that's bigger than 38. So if this is 1, I can't multiply it by a number and get a number bigger than 38. This can't be 1. Similarly, it can't be 2. The only other options that can go here are 4 and 5 if this is going to add up to 15. Could it be 4? 4 times the largest number I have left, which is 8, only gives me 32. You can subtract something from 32 and get 38? No, that ain't going to happen. So this has to be equal to 5 right here. This is 5. That forces this to be equal to 1, and those 2 guys are gone. So what do I have left? My largest number left is 8. This has to be a big number up here because when I multiply it by 5, I have to get more than 38. This has to be 8. The only number that I can multiply by 5 to get a number that's bigger than 38 is 8. 8 is gone. 8 times 5 is 40. So I subtract 2 to get 38. And now I'm essentially done. 2 plus what? Plus 7 gives me 12. Well, I need 3 more here. 2 plus 3 plus 7 gives me 12. That's gone. Did I forget to cross out a number somewhere? 2 and 3 are both gone. I think I forgot to cross out the 2 when I wrote it there. And so now I can either go this way or go this way. 8 divided by something plus 6 is 8. So I'm going to add last. So something plus 6 equals 8. 2 plus 6 equals 8. So this thing must equal 2. 8 divided by something. Hey, look, 4. 8 divided by 4 is 2, and that's the one number I had left. Does that check out? 4 minus 1 times 3? Well, what I would do is 1 times 3 first, which gives me 3. And 4 minus 3 gives me 1. Looks like everything checks out here. So that's the end of this quiz. I guess I'll end the video here.